Hi students, this is Mr. Yao. In this video, I'm going to talk about the last two examples of number 4 basic of circles, which is about arcs and sectors. So let's have a look at example 9. I'm specifically making this video to talk about a few different methods for both example 9 and example 10. So example 9 is, you can see you are given the sector area and is asking you to find the arc length. And example 10 is you're given the arc length to find the sector area. So nothing involves the angle. That's why there are a few different methods to do them. The first method, let's actually use the central angle. Since you are given the sector area, let's quickly review the two formulas that we have learned. One is the arc length. Well, I'm actually going to write it here. The length of the arc over the circumference, which is 2 pi times r. That is the same as the measure of the arc over 360. Again, the idea is part over whole. That's how we set up the ratio. Okay, and then the other formula we have is about the sector area. So the area of the sector, but this time you can't compare it to 2 pi r anymore. We're going to compare to the whole circle's area, which is pi r squared. And on the right side, measure of the arc over 360 degrees. So in this case, you are given the sector area, which means you actually are given right there. And since d is 6, we can actually know the r is going to be 3 centimeters. So you actually know the sector area and you actually know the pi r squared. So in that second equation, the only thing that is missing is clearly the measure of the arc. So that's what we're going to find first. And the measure of the arc is the central angle as well. So basically, we're finding out what this angle is before we move on to the arc length. So let's put things in. The sector area is given as 2 pi. So I'm using this formula. Over pi, my r is 3, so 3 squared. That equals to the measure of arc, which again is an angle. It's the central angle over 360 degrees. I can get rid of the pi. And if we want to find the arc, the measure of the arc, I'm going to multiply both sides by a 360 degrees. That is gone on the right side. I basically have 360 times 2, then divided by a 9. So the measure of the arc is going to be 80 degrees. Now that I know it's 80 degrees, let's look at the other formula that we have. I actually know this is going to be 80 right here. I know the r, so I can clearly use that to find the arc length. So let's set it up. The arc length over 2 pi times the radius, which is 3, that is the same as 80 degrees over 360 degrees. So in order to find the arc length, I'm going to need to get rid of the denominator on the left side. So I'm going to multiply both sides by 6 pi. 6 is to get rid of the numbers, and pi is to get rid of the pi in the denominator. And I just need to simplify the right side. 80 times 6 is 480 over 360. So the arc length is going to be 480 over 360, simplified to be 4 pi over 3. Don't forget a unit. Centimeter. So that's the first method. You can actually use both formulas. And we were finding the central angle, or the measure of the arc, which is an angle, and then use that to convert to find the length, the arc length. So that's the first method. Now the second method. Well, besides having these two formulas, we also have formulas that involves radian. So that's what we're going to do with the second method. Let me remind you what the formulas were. The arc length formula was the radius times the radian. And the sector area formula was r squared times radian divided by 2. I've talked about how to convert from a degree formula to the radian formula in the previous video. You can check there. Okay, so let's see. In this question now, we know the area, so I can actually start with the second formula. The area itself is 2 pi, which equals to r is a 3 squared times theta over 2. So I'm looking for theta. I can actually multiply both sides by a 2. So that's going to get rid of that. Then divide both sides by a 9 to get rid of the 3 squared. So theta is actually 4 pi over 9. And as soon as I have that, since the arc length is going to be the radius times the radian, so the arc length is actually going to be 4 pi over 9. That's the radian we just found, times the radius, which is 3, And that is going to be simplified as 4 pi over 3 centimeter as well. So that is the second method, which we're going to use the radian. There is a third method. Method 3. Method 3 is actually using the first method, but more directly, because in the formulas we have in the arc length and the sector area, we see on the right side of the equation they're both equaling measurement of the arc over 360. So to make it a bit shorter, we can actually just link the left side together. So arc length over 2 pi r is the same as the sector area over pi r squared. So in that case, let's actually put in everything that we actually know from this question. The arc length over 2 pi, my radius is a 3. On the right side, the sector area is 2 pi over pi times r is 3, so 3 squared. In that case, if we want to simplify both sides, I'm going to multiply. If I want to solve for the arc length, I'm going to multiply both sides by a 6 pi to get rid of the denominator. On the right side, the pi and the pi cancels out. We actually have a 12 pi over 9. So the arc length is going to be 9 pi, no, not 4 pi over 3 as well. So that is the third method. First method is using the angle and actually finding the angle. And second method is using a radian. And third angle is just directly find the link, the connection between the arc length and the sector area. One thing I do want to mention, if the question is asking to find the perimeter, so right now it's asking for the arc length of the shaded area. If the question is asking for the perimeter of the shaded area, not only do I need to find this arc, I also need to include 2 radii. That means the answer would be 4 pi over 3, and plus each radius is a 3. There are 2 of them, so plus 6 centimeter. That's if the question is asking to find the perimeter of the shaded area. So that is example 9. Example 10 is basically going backwards. You're given the arc length and is asking to find the sector area. So I'm still going to use all 3 methods. The first method, again, is we're going to find that central angle. So here's the setup. It's the sector area. Well, sorry, this question is giving you arc length. So it's the arc length over 2 pi times r. In this case, d is 6, so that means r is 3 as well. So it's 2 pi times 3. That equals to the measure of arc over 360 degrees. In order to solve for the arc length, I'm going to multiply both sides by a 6 pi. And the right side is going to, multiply both sides by a 6 pi. But I actually made a mistake because the arc length, we actually know it. So we're actually not multiplying by 6 pi. We actually know the arc length is 3 pi. Okay. So that is the arc length. So we're going to actually multiply both sides by 360 degrees to get rid of the right side. And the left side, we're going to end up with 360 degrees times 3 pi over 6 pi. So the pi, of course, cancels out. But we still have the 3 there cancels out. So it's 360 over 2. That means the measure of the arc is 180 degrees. Well, unfortunately, the graph is not fully right. That does not look like 180 degrees, but just know that is the result that we actually got from the actual calculation. So since we found the arc measurement of the arc, we're going to now find the sector area. So the area of the sector compared to the whole circle's area, which is pi times my radius 3, so 3 squared. That equals to, on the right side, 180 degrees over 360 degrees. And I'm going to multiply both sides by 9 pi. So my sector area is going to be, on the right side, 180 times 9 over 360. That is going to be 9 pi over 2, don't forget a unit, feet squared. That is the first method, which is to find the angle and then use the angle compared to 360, find the other one. That's first method. Second method is, of course, you finding the radian. So we're given the arc length. The formula for arc length is r times theta, which in this case r is 3, so it's 3 times theta. That is 3 pi. we can easily solve, divide both sides by a pi. Theta is actually pi. Now we can use the sector area formula, which is r squared times theta over 2. So r3, 3 squared times my theta is a pi over 2, simplified to be 9 pi over 2 feet squared as well. That's the second method. Lastly, we have a third method, which is where we're going to use the formulas directly. So arc length over 2 pi r is the same as the sector area compared to the whole circle, which is pi r squared. So let's put everything in. We know the arc length is 3 pi in this case. On the bottom is 2 pi times the radius is a 3. On the right side, our sector area, which is the one we're trying to find, over pi times r is 3, so 3 squared. We can multiply both sides by 9 pi. Pi is going to cancel out, the 3 is going to cancel out. We're left with a 9 pi on the top and a 2 on the bottom. So the sector area is also going to give us 9 pi over 2 feet squared. So these are the 3 methods for example 9 and example 10. And that's everything for this video. Thank you.